Hello and welcome to The Explainer. Today, we're diving into a pretty amazing technology that's totally changing how the stuff we use every day gets made. It's all about making sure those products are as close to perfect as possible. So, let me ask you a question. Picture a factory line turning out millions of cookies. How on earth do you spot the one that's cracked, or find a tiny, almost invisible scratch on a car door that just came off the line? It sounds nearly impossible, right?
Well, for decades, it pretty much has been. This has been a huge headache for manufacturers. Finding those random, unexpected little flaws, the ones you can't predict, has been one of the toughest nuts to crack in the entire industry.
So why is this so hard? Let's get into it and take a look at why the old ways of doing things just can't seem to get the job done. Okay, so traditional inspection systems are, well, a bit rigid. You have to program them with a strict set of rules. You literally have to tell it a scratch looks exactly like this. But the real world is messy. A good product might have slight changes in color or texture. The lighting in a factory can change, creating glare. And honestly, it's impossible to create a rule for every single thing that could possibly go wrong. This leads to a ton of false alarms, or way worse, it misses the actual defect.
But what if you could do it differently? This is where AI steps in and completely flips the script on how we think about quality control.
Instead of trying to teach a computer an endless list of everything that could be wrong, what if you could teach it what's right? Imagine a system that just gets it. It develops a kind of an intuition for what a perfect product looks like, including all its normal, okay variations. So now, anything that doesn't match that idea of right immediately gets flagged. Now, that might sound super complicated, almost like magic. But the way this AI actually learns is, you'll see, surprisingly straightforward and pretty elegant.
It's really just a simple, three-step process. First, you just show the system a bunch of good products, the ones without any flaws. That's it. Second, the AI takes over. It analyzes all of them and builds its own model of what normal looks like, taking all those natural variations into account. And third, you just let it run. It now automatically spots anything that's different from that baseline it learned.
Now here's the part that's really mind-blowing. When you think of training an AI, you probably think of millions of images, right? Well, with this system, you can create a really powerful inspection model with as few as 40 images. Just 40. That's a total game changer, because it means setup is incredibly fast and this tech can be used almost anywhere. And the system is smart about how it learns, too. It has two modes. In the first, it learns only from good examples. This is perfect for catching those weird, unexpected flaws you didn't even know could happen. But you can also use integrated learning, where you show it both good and bad examples. This lets you really zero in and train it to find specific, known problems with incredible accuracy. You get the best of both worlds.
Inside this system, you've basically got two powerhouse tools. First is AI classification. Think of this as a sorter. It gives a simple okay or not good, which is perfect for making sure the right part is in the right place. Then you have AI detection. This is more like a super-powered magnifying glass. It scans a product surface and creates a heat map to highlight the exact location of the tiniest scratch, chip, or stain.
Okay, so that's all the theory. Now for the fun part. Let's see how this stuff actually works on the job with some real-world examples. First up, let's head into the world of automotive and metal manufacturing, where every little detail matters. Metal parts are a classic challenge. They're often shiny, they might have oil on them, or harmless hairline marks from the casting process. All that noise would completely confuse an older system. But this AI learns that all that stuff is normal. It learns to ignore it and focuses on finding the real problems, like a critical crack or a chip. It can even look at a whole assembly and tell you instantly if a clip is on crooked or missing entirely. All right, let's switch gears from heavy industry to something we all have in our kitchens: food and packaging. This is where you can really see the AI's flexibility. Let's go back to those cookies. You know how no two cookies ever look exactly the same? Different shapes, different baking colors. The AI learns that this variation is perfectly fine, so it only flags what you actually care about: a broken or cracked cookie. Same idea for a complicated bottle tip. It can check the seal perfectly, even with weird shapes and reflections.
And finally, let's zoom way in and look at the kind of precision you need for electronics and other everyday goods.
Okay, ever tried to inspect something wrapped in shrink wrap, The glare, the reflections, the normal wrinkles, it's a nightmare for a camera. But again, the AI learns what good wrinkles look like and only flags the actual tears. Or take something super complex like an electronic coil. It can spot one tiny break in a wire within that intricate pattern, a task that used to be incredibly difficult and slow to set up manually.
So when you put this all together, what does it really mean? What's the big picture impact of all this? Well, the big takeaway is that we're looking at a brand new standard for quality. It's faster to set up, it's more accurate because it catches things you didn't even know to look for, and it's so much more flexible. But this isn't just about making a factory more efficient. This is about us. It means the car you drive, the food you eat, the phone you use, they're all safer and more reliable. It's about building trust and safety right into the things we depend on every single day.
This quote from the source material really sums up the genius behind it. It's an algorithm that detects anything other than non-defective targets. It's not about knowing every flaw. It's about deeply understanding perfection and flagging anything that isn't that.
And that kind of leaves us with one last big question. If AI can learn to see what's right to perfect the products we make, just imagine what else it could do. What's the next so-called impossible problem, maybe in science or medicine, that it could learn to solve just by shifting its perspective? It's a pretty exciting future to think about. Thanks for watching.